Hello and welcome back to K-Tech Designs. My name is Seth. In this video, I'll show you how I made this snap clip in FreeCAD. I designed it for 3D printing and for it to be actually usable. So in this video, I'll show you how I made the male half and the fitting female half of this clip. And with that, let's get started. So as always, let's start from the home page and let's create a new part. Let's change our workbench to the part design workbench. I'm going to create a part container, and then we'll create two bodies within that container. I'm going to rename this one to male and the second body to female. Let's get that E in there. Alright. Now with the male selected, let's start a sketch, and I'm going to sketch on the top plane. Now this sketch is going to be the most complicated part of this, so bear with me. Let's start with, or I'll model the male end on this side of the vertical axis here. So let's just start with a rectangle. We'll get the basic shapes out of the way. And then we'll start with the second rectangle this way. And then I'll make a sort of an offset there. Let's make these coincident, if I can pick the correct type. And then let's trim this middle. Add some symmetric constraints here. And we'll go ahead and dimension this to 22 millimeters long. Make those coincident. My gosh. Make sure you're clicking the correct parts. And I'm going to make these two equal. That needs to be vertical. Alright, let's drag things closer. That's better. So let's dimension this outer body here. 25 millimeters. And I'll make those symmetric as well. Okay, starting to take shape. Let's dimension this leg. .5. Actually, that is just 20. So now that's our basic shape. Let's dimension this leg here to be 4 millimeters. And actually, I'm going to need to offset these. So let's just draw a little line here. And then I'm going to trim this leg out. Oops. And delete that leg. And this needs to come up a little bit, about 1/2 millimeter. There we go. Okay, now we're ready to model the flexing snap feature, which is one of the most important parts of this design, of course. Actually, let me just quickly dimension these. It's just 3 millimeters thick. Okay, that's locked in. So you're just loose. We'll make these equal. Okay. I'm actually going to come back in and do some fillets, but I just want to lock down that shape to begin with. So we got this leg here and this leg here. Now we need to draw some arcs. Do this one, draw a little one at the tip, and then one more here. And let's draw our locking leg. And we'll draw a tiny leg up this way. Put an arc on there. I'm going to add a tangency. That should have been vertical. Second tangency. Oh, I see. Sorry about that. I'm going to have to delete all of these because, come on. I missed to mention that completely. Let's try this again. So actually this leg is 22. And this should actually be back a 0.5 millimeter. So I'm going to grab these two vertices here, 0.5. Yeah. And then these two vertices should be 20. There, that looks right. Alright, so let's go back to our snapping latching feature and let's add some tangencies. It can be tricky adding tangencies to parts. Sometimes the program gets really confused on where the tangency should be, and you'll get really funky geometry. So if it breaks, you just have to start over. Like there's no way to fix it. But that one turned out well. Looks like that I picked fairly reasonable points, and the program was able to figure it out. So now this, we need to keep track of this thickness. This is an important part of the design. And then also this gap here. So as the part fits into the female part, it's going to have to move a certain distance. So you need to make sure that this distance is not longer than this. Otherwise you can't flex the part out of the way. And this part needs to be sufficiently thick so that it can flex. Not too thick or else it won't flex, and not too thin so that it doesn't fail with repeated flexing. So let's make these two endpoints symmetric. Let's make this radius 3.5 millimeters. Oops. Let's make this radius 9 millimeters. Let's make this angle 45. We'll make this height 2 millimeters. Oops, don't do that. This radius should be 1 millimeter. Okay, and I did not dimension a radius on this part. For this part, what I did was let's just go ahead and select all of these edges. Oh my gosh. Even these two. We'll select our horizontal axis and let's do a mirror. Okay, these points are not going to be connected, of course. So let's get them all connected. And so what I did was I made a line between these two. And then I dimensioned this point to this point at 3.5 millimeters. So now we need to dimension this leg thickness. So let's add another line. I'll just make it radial like that so that we have a point to grab onto. We'll grab those two vertices and we'll dimension 1.5. Okay. And then let's do the same kind of deal over here for this tip. That way we have a tangent point to grab onto, and we'll dimension it from the vertical axis 2.3 millimeters. It's getting kind of busy here. And then finally I'll just add a dimension here and that tip, and we'll make it 11. So now that feature should be pretty locked in except for its width here. I'm going to add some symmetric constraints as well. I'm going to add in another tip control here, and so we'll measure from, that should be horizontal. Okay, so we'll measure from this point to this point vertically 15 millimeters. Alright, so let's go away. Let's make these symmetric as well. Alright, that's looking pretty good. Connect those two together. Add in a tangency. I'll also make these equal right away before I forget. So let's make these 20 millimeters apart. Oops. Not sure what else is missing a constraint. Oh, of course. These two tip points should be symmetric. And those are equal already. I'll just take that off so I can make these equal. Hold on. What happened? I lost a constraint. This is... what the heck? That was supposed to be 3.5. Now these two corners I should be able to dimension to 2 millimeters. So I must have messed something up in this sketch somewhere. Oh, let's get that out of the way. That's supposed to be to here anyway. 2. Sorry, 3. What? What? Okay, I'm just gonna add in this line here. Okay, that locks it in place as it should be. I don't understand why these aren't going to 2 millimeters. Other than having this leg here, it could be an issue. Let's see if I can just do one instead of both. 2. Okay, that works perfectly. Oh, they were already equal. Maybe you didn't like that. Alright, sorry for that distraction. Adding this in seems to be all it really needed, and making it tangent so that these points were truly at the apex of this curve. Alright, so we're done with the clipping part here. I'm going to add in some sketch fillets. I've started to use more and more sketch fillets. Let's do a sketch preserving or a constraint preserving sketch fillet. because the filleting feature just breaks all the time. That topographical naming issue is just too much for me to deal with. So if you need a fillet, put it in the sketch. Alright, so I'm just going to touch these lines here. Another filleting area should be here and here. Let's do the tip here as well. And that should be good. So now these two should be equal. And they're 0.5 millimeters. These two are equal. And they're 1 millimeters, but I'm going to make them equal to these inner ones as well, because those are all going to be 1 millimeter thick, or 1 millimeter radial. 1. These outer ones are all the same, so I'm just going to grab these 3 and make those equal. I probably lost a constraint or two, so let's bring this back in. Okay, so that should be vertical. Alright, that wasn't too bad. That looks good. Let's close that. Let's create a pad. And I'm going to make it 6 millimeters tall. Click OK. You can see that most of the work was done in the sketch. And now all I'm going to do is I'm going to add a cross member here. And I'm going to add some rails on the top here. And this helps ensure that when the clip goes in, it's fairly straight and it doesn't wobble back and forth. I noticed that in my first design, without having these rails on the top, that you could actually you could rotate this part inside the female part enough that one of these edges could come out, and then the clip would fail. So having the rail in the middle, and then of course a feature on the female part that retains it, will keep it from rocking back or rotating inside the female part. So let's do the cross member next. I'm going to do a sketch on the front plane here. I'm just going to draw a rectangle, close that, not close that, hide this part, and then we're going to, I'm going to add a split edge, and I'll make these two edges equal, and that way I can dimension to the middle. Let's make that distance 32.5. I'm going to make this overall height 3 millimeters. And then we'll make these, make the width 4.5. And I'm going to add a sketch fillet on the top edges here. And we'll make those 1 millimeter. Okay. Close it, bring back the visibility of the pad. And then we'll do a symmetric extrusion. I believe that's 19. Don't know why they didn't update visually. But I'm just making it the same length as that inside there. And the reason why I've modeled it this way is because this plane represents the printing plane. Since I want to 3D print these and I don't want to have any supports, obviously if I printed it like this, then I'd have to have support material under here. But I want this to be smooth. I don't want it to have remnants of broken away support material. Alright, so now let's make the rails on the top. I'm going to add a sketch on the top plane. I'm going to close it, and I know the part is 6 millimeters thick, so I'm going to change its attachment to be 6 millimeters above the top plane. Go ahead and edit that sketch. And these are going to be pretty simple. I'm just going to add two long, thin, rectangular features. I'm going to dimension this to 1 millimeter. Its overall length is 20. And its thickness, I'll do it this way, is also just 1 millimeter. I know that this leg is 4 millimeters thick, so I'm going to dimension these, I'm going to make these symmetric, and then their dimension will be 4. Those are that way. Let's make these equal, and these equal as well. And that finishes that. And then we'll extrude them. Pad only needs to be 0.5 millimeter tall. It's just something above the rest of the part that I can use to be a retainer. Click OK on that. And then I'm going to add some sketch chamfers on here. Oops, I just need one. We need to do 0.499 because you can't do 0.5 on a 0.5 leg, which makes 0 sense, but that's how it is. And then we'll grab all of these edges. Perfect. And now that half is done. Male end is ready to print. So like I said, most of the complexity was in the sketch. Because I'm designing it for 3D printing, I don't have a lot of complexity options in the first place, so it's going to be a simple boss extrude with retaining features. So let's go to the female part. I'll double click that body so all new features will go there. So let's create a sketch on the top plane. And this is going to use a shell feature. So we're just going to create a box here, roughly same size as this part. Let's dimension from that vertical axis. Oops, 22.3 millimeters. I want a bit of a gap here so that the part is able to slide fully over and past this tip, but not too far because I want it to actually latch. Let's dimension this back leg to 4 millimeters. Then I'm going to make these symmetric, and their length is 25 millimeters. Now when we extrude this pad, we're going to need to do it in 2 dimensions. Actually, first, let's bring this sketch down 1 millimeter for clearance. Let's go back to the pad. We're going to do 2 dimensions. This top dimension will be 9.5, and the bottom dimension will be 1.5. Now for this one, I am going to put a radius on the outside edge first, and that's because I want the shell to have an inside radius. Okay, so 2 millimeters on that, 2.5 millimeters on that radius. So now we'll click this face, and we'll come over here and click thickness. And I want the thickness to be just 2 millimeters. It does seem wrong. Oh. Make sure that you're pitching the direction of the thickness. The thickness will be inwards, meaning that your sketch is your outer boundary, not the inner boundary. So that looks pretty good. That'll be nice and tight, but also not allow a lot of motion in the part, in the fit. Click OK on that. So let's hide this male part for a second here. I'm going to grab this inner edge and I will put a fillet on there. It doesn't need to be very large, 0.7, and that's for dealing with a future feature that I'll have to add on there. Now let's bring the male part back in, and we need to create our cutouts. You know, the latching cutout, and also where your fingers will compress the tabs. And a convenient way to do that actually is to take this male sketch. Let's go to the draft workbench and we'll go ahead and clone it. Drag that back into the female. Now what cloning does, and I didn't actually know this until Mango Jelly showed me how to do it. When you I knew how to create a clone, but I didn't know that it actually will be a live update of the sketch that is cloned on. And that's extremely convenient, especially for the way I'm going to use it now as a reference for where to put these cutouts. So thank you, Mango, for a very simple but powerful tip there. Alright, so let's create our cutouts. I'm going to go to, we got to go back to the part design workbench. Create a sketch on the top plane, and I'm going to hide this model. And let's hide this model. And now you can see our sketch is visible, and we can copy some of the important edges here. So we want this one, and that's probably it because I can mirror the cut feature. So let's start drawing the cut feature. I want a straight leg here and one here as well. I'm going to take this reference geometry here for a tangent C control, and then I'll add an arc between this point and this point. So let's make these tangent. Let's make these tangent. And I'm going to make these parallel. And then I'm going to dimension. No, see, yeah, that won't work. So I'm going to add in another reference line, construction line, and I'll make that perpendicular to our reference line. And then I will dimension this to 0.5 millimeters. And again, that is just to create some clearance between the parts so that they slide together, but I don't want a lot of clearance because I want them to actually lock together. So I'm going to take these sketches here, I don't need that one, and then we'll create a mirror that geometry. Let's make these equal right away. I'm going to make these symmetric. Where is it? Sorry. And I guess I'll make these equal as well. So now we can dimension this to 25.1. And if you remember, 25 is the overall length we're using for this part. And I've noticed that sometimes when you do size on size cuts, there will be an infinitely thin plane still visible. So I often cut over what the part actually is just to ensure that that plane doesn't happen. Let's create another one of those tangent features here. Well, I'll just dimension it right away. And maybe I don't need that one. The spacing between them is 6 millimeters. Sorry. The spacing to the axis is 6 millimeters. So I must just be missing like an equals here, and then possibly a symmetric to make sure that they are parallel. I must have an extra constraint somewhere, probably the equals here. Nope, still not right. Now see, I want those equal. Maybe I have to get rid of one of these symmetrics here. Like this outer edge one. Oh, somehow I've lost my parallel on that. Oh, those weren't actually tangent. Sorry about that. Alright, that looks good. Bring back our visible parts. We can hide that for now. And then let's do a cut. And I'll do a through all. Reversed. And then I guess I'll change the position of that sketch. Wrong direction. So let's do like -3. Alright. So that ensures that the part is fully cut through. So now that's looking pretty good here. You can see we've got quite a lot of distance of overlap here. So we'll have a strong clip. So I'm going to add a few chamfers. We'll chamfer this surface here. Sorry. What did I do? Oh, it's too big. I'll make it 0.6. So this chamfer obviously is just to make the part insertion easier. You could even come in and do a chamfer on this top and the bottom at the end of all of this instead of just the way I did it there. But it's a little flaky, so I didn't do it. I just relied on the fact that the extruded material is not going to have a sharp edge. It's going to be a little bit rounded anyway. Alright, so then I'm going to add a fillet to this edge here and this one as well. 1 millimeter is sufficient. Let's create this pad on the end here. This one will be easy because we modeled this pad on the top plane. This one can also be on the top plane and merge nearly seamlessly. So let's just make 2 rectangles here, and then I'll trim out the inner leg. Okay. We dimensioned this to 4 millimeters earlier, so I'll just plug in 4 there. The overall length should be 19. And the wall thickness is 3, just like the other one. Alright, and then we'll add symmetric constraints as well. I don't really need that. I don't need this one. I don't know what that came from. Oh boy. What did I add? I'll undo. Okay. Oh, there we go. Sorry, I don't know what I added there. That was weird. We'll make these symmetric as well. Interesting. Connect those. And then make this vertical. Okay, and then I guess we'll make these equal. Oh, I don't know if I even added that. This should of course be 25. Okay, so that gets us to the edge. Then I'm going to add some fillets here. These two being equal and being 1 millimeter. And then the outer ones also being equal and being 2 millimeters. Okay, set those equal again because I guess I deleted them when I added that fillet. Close that, pad that, 6 millimeters, and that looks good. And you can see that I picked a radius here that produced a nice solid line. It's it doesn't make the design good or bad, it just looks good. Now let's add in our cross member. So that's front plane. Gonna hide that. Again, it's just a rectangle on the top plane. Let's split that as well. Make those split lines equal. The overall width is 4.5 millimeters. The overall height is 3. And we'll make the distance 12 millimeters. I'll add in my sketch fillets. Make them equal. And they are 2 millimeters. 1 millimeter. Okay, we'll bring back in the pad. Double check. It looks like it's centered. Yes. Close that. Pad that. Symmetric. 19. Click OK. Alright, that's looking like it's pretty much done. But we're not quite done yet. So like I said, we've got this retaining feature in here to prevent the part from wiggling back and forth. And so we need to create a retaining or a mating feature. I'll just hide that inside here. So it's essentially just going to be a raceway. We can do that pretty easily by sketching on this plane here. We'll hide that. We're going to do 2 little rectangles on either side to create our channel. And let's make these symmetric, of course. We'll make their distance between each other 4.3. So if you remember, that inner leg is 4 millimeters wide. So we're just having a very tight 0.3 millimeter clearance total. Let's make these equal, and then these legs equal. I'm actually going to remove these vertical constraints here, if it'll let me, because I want to have a little chamfer on there. And I'd rather do it as a sketch than as a feature. It's also going to help with 3D printing. I'll show you what the orientation will be in a minute. So I'm going to go over to my constraint panel to find those constraints. Alright. Let's make these. This could be like 60, 120. So that'll be 60 degrees. I'll make those symmetric. The overall height needs to be 0.3 millimeters. I know that the inner legs were 0.5, but I don't want this to be. I'm trying to reduce the friction, I guess is what I'm trying to say, between the parts. You know, you just need something for those legs to bump across, and there's not much else for them to go, so there's like no chance of them slipping underneath here. And yeah, so 0.3 is, I found, was sufficient to do what I needed it to do. Let's make this leg 3.5 millimeters wide. So then we'll just need to, I think making these legs equal should be enough to lock it in place. Oh, right. From the top to this axis is 6.5. Bring back in the pad just to double check. Left. Yep, that looks perfect. Now I know I skip through a lot of these dimensions, or I know I go through these dimensions fairly quickly, and I don't always explain where they're coming from. So as I'm building this model and I'm deciding what features to put in here, I don't know exactly what their dimension is going to be. I just know I want it, for example, to be attached to this surface here. So when I get around to modeling this part of it, I'll close it out. I'll go back into the previous sketch to see where that dimension is, and then I'll come back to the sketch and plug it in. Close that. That's done. Okay, that looks good. Now what I'm going to do is I'm going to pad that in the reverse direction, and looks like I have 21.5 as the overall length for that. So that looks perfect. Now, like I said, I plan on 3D printing the part in this orientation, and that's because when it comes to printing without support material, your 3D printer can do a certain amount of bridging. You'll want to test what your settings are capable of handling, but without worrying about it too much. This distance is pretty small. It's 6 millimeters, so that's like a 1/4 inch. And so printing it this way ensures that I can have some bridging, and I don't have to worry about severe drooping or anything like that. If I try to print it in its modeled orientation, that's a pretty sizable gap, and there's also a little feature in here that just will not print. So you'd have to have support material, and I don't have soluble support material, and breakaway support material will just be a nightmare. It'll make the part useless. So you got to model it this way. Okay, I've been rambling way too much in this video. I apologize for that. So we just need to mirror this. So the part is designed, the male part is designed to print on this surface, so there's only one retaining feature. I can't do it on this side as well. But the female part, because of the way I'm printing it, I can actually put those on both sides, and that would actually be good. That's a good way to design this part, because the male part could go in either way. It could go in this orientation, it could be flipped and go in as well. And I want it to clip securely in either situation. So I'm going to hide the male part again. I'm going to create a datum plane for this. I need to create a plane. So I'm going to click the XY plane, which is the top plane, and I'm just going to make it 3 millimeters above that. Click OK on that. And I usually like to, after I create a datum plane, I really like to move it to the beginning of the body so that I don't lose it, and also because it's not referencing anything in the body, so it can be moved there, and it makes the model more stable. So we'll take this pad. I think I could just pick symmetric, and then I'll add my selected reference, which is that plane. And there you go. Let's hide that. Don't need to see that. And that's it. You're done. That is a fully modeled snap clip. just move this male part out. So if you take -35, I think is about what works. Okay, so that is how you model and design a snap clip for 3D printing in FreeCAD. So we went through modeling the male part, taking note of some of the design features such as how thick this wall should be, how long this leg should be, what the space between this point and this point should be, and all of that to create a functioning and reliable clip. Thanks for watching this video. I hope this was informative and interesting for you. Let me know what you thought in the comments. Please leave a like if you liked the video. Again, thanks for watching, and I will see you in the next one.